This is section 11.3, solving quadratic equations by graphing. Okay, so we're going to do some stuff similar to what we were doing in the previous two sections where we're dealing with the quadratics or the parabolas, and then we're going to do some graphing, but this time we're actually looking for like an ordered pair for a solution. Okay, so it'll be similar to what we were doing before, just slightly different. Okay, so we're still going to be dealing with the form of our quadratic equation. So typically what we have is y equals, and then you got some number in front of your x squared, some number in front of your x, and then your c is at the end, which would just be a number. The ones that we're going to be working on for today and then the next couple sections here, we're always going to think as our y being equal to 0. Okay, so our y we're always going to plug in instead of having, an actual letter there, it's going to be 0 when we go to solve these out. What that does and why we need y equals 0 is it helps us to find our roots. Okay, our roots are our solutions to these quadratic equations. Okay, and they're found by finding the x-intercept, which would be where it's going to cross the x-axis, which would be when our y is equal to 0. That's why we have to have y equal to 0 on these. So you have three different types of situations you could have with these. You could have one solution, two solutions, or no solutions. A one solution situation would be when you've got a graph kind of like this, where it's only crossing that x-axis in one spot. So this would be a situation where it's got one solution. Now you might also have a situation where there's multiple solutions, so two solutions. So that'd be kind of your arc shaped is a little bit down like this, and it could be crossing there and crossing there. So with that picture you would have two different answers. So one answer here, two answers here, and you might have situations where there's actually no solutions. So if you can see, this graph is kind of way slid down there and the arrows are going to keep going in that direction forever, so they're actually never going to cross that x-axis. So that would be a situation where you would just write no solutions. Okay, so let's start with the story problem here. So it says, suppose we have the function f of t is equal to negative 16t squared plus 29t plus 6. This represents the height of water at any time t seconds after it's left its jet, and then we're supposed to find the number of seconds it takes for the water to hit the ground. Okay, so basically what we've got here, they write this in function notation as h of t, but really that's similar to like y equals negative 16, and then instead of the t usually we see them as x plus 29x plus 6. Both of these are basically the same thing, they just write them with different variables and slightly different notation, but it means the same thing. Okay, so basically what we want to do here is there's water that's shooting out of a jet. So say we got a graph kind of like this, we got some jet right here, and there's water shooting out of it. Well, when you shoot water out of something, if it's kind of going up like that, it's got to come down somewhere. So what we've got to figure out is after how many seconds that water is going to hit the ground. So basically we want to find where this jet is going to come across and hit that x-intercept. Okay, so where it's going to hit that x-axis. So what we can do is you could graph it by hand like we've been doing in the previous sections. I would encourage you, if you have a graphing calculator, to use it because this will speed up the process times at least 100 times faster. Okay, it's super easy once you get it figured out, and it's going to save you a whole bunch of time. Now, if you don't have a graphing calculator, don't worry. There is a website. It's called Desmos, and I think it's like desmos.com or something like that. That will allow you to do graphing. So if you don't have a graphing calculator and you're trying to do this stuff at home, you can go to this website here, Desmos, type in your equations, and it'll do something similar to what we've got here. When you take the tests on it, if you're doing the test at home, then you can use that. If you're doing the tests at school, I'll want you to use one of these graphing calculators, which I do have some extras at school. So knowing both ways is a good thing to know. Okay, so with your graphing calculator, if you need to graph something, we always go to this y equals button here. If there's stuff in there, we clear it out. And basically all of our equations, when we use a calculator like this, have to be y equals and then the rest of the stuff. If there was stuff over here like numbers with that y, we would need to solve that out for y before we could use our calculator. Okay, but this one's good because it's y equals all the rest of the stuff, so we can plug in. Okay, so what we're going to do here is we've already got our y equals typed in. So now we need to type in negative 16x squared. So my negative, when you do this, you have to use the negative button that's below the 3. If you try to use the subtract sign for this, it'll give you an error. So always remember to use this as your negative sign. So negative 16. And then for your x, when we plug in that variable, you want to use this xt empty set n button here right under mode. That'll give you your variable of x. Now, with our negative 16, x, it's actually to the power of 2, so we need to take and square that. So usually I use this little caret button here. It's right above the division sign. So I do that caret, and then it kind of raises it up there. Depending on the version of calculator you have, I know my other calculator actually puts a little picture of the caret there, and then the 2. This one just arrows it up so it's kind of raised up there, and then puts the 2. Either way is fine, it really doesn't matter. I think it's just the versions of them. Now if your version is like this, where you can see like now my little cursor is up with the 2, you want to make sure you arrow down or arrow over before you type in your other stuff, because if you don't, it's going to type it in up top. So if I did like plus 29, see how it's small there? I don't want that, so I'm going to delete that out. And I actually want to be down to do my plus 29. Then I put my x with that, and then plus 6. So now I've got my full equation typed in there. So now to see what this looks like, I push the graph button, which is in the upper right hand corner. Okay, so then after a few seconds it'll graph. Now what this looks like here is it looks like it's going up pretty high and then coming down pretty sharply. If you want to see what the full graph would look like, you could change your window here. So you can either change your window by going in here and kind of changing it. You can go 10 by 10 is usually what it's set up as. This one looks like it's set up slightly different. You can also use the zoom button here, and we would want to zoom out because we would want to make it bigger. So if you just go down to the third one there for zoom out, and then once it comes back to the screen, you just push enter. That kind of zooms it out so you can see more of the graph, but like I said, it doesn't necessarily matter if you can see the whole thing for this one. Some of them you will want to see the whole thing, but you don't have to in this situation. So I'm going to go back to my regular. So zoom, if I need to go back to the regular, Z standard takes me back to what it originally looked like. So I go Z standard. Now what I want to do is I'm looking for those spots where it's going to cross. So really, it's going to cross in 2 spots here. It's going to cross right here, and it's going to cross right here. To be able to find those spots where it's crossing that x-axis, what I can do is I can go to my second button here, which is like a shift, and then that puts a little arrow up here that says like my shift is on. Then I want to go to the one that's above the trace that says calc, and I want to push that. Okay, so then it should say calculate, and then there's different things that we can calculate. In this case, when I'm trying to look for my solutions here, I want to calculate the 0 because I want to know when my y is equal to 0. So then I arrow down to 0, push enter. Now it's going to ask me some questions here. So the reason it's asking me questions is because there's actually 2 spots where it crosses. So we've got to kind of tell the calculator which one we want to figure out, if we want to figure out this one or this one. So what you do is you see this little cursor blinking. I want it to be so it says left bound there. I want that cursor to be on the left side because I'm going to try to find this one right here. So I'm going to put that on the left side of that. So I arrow to where it's on the left side. Then I go enter. Now it wants me to arrow on the right side. So I enter to where it's above that. So then I go enter, and then guess I just push enter again. And then it tells me there my y is 0 when my x is negative 0.1875. So we'll write that in. So negative 0.1875, and my y is 0. So that's one of my situations, or one of my solutions. Now I want to find this one over here. So I do the same thing. I can go second, and then my trace button, which is calculate above it. Then I'm trying to calculate 0, so I arrow down to that. And then again here I need to pick my left bound side and my right bound side. So my left bound would be anywhere that's on this side of it. So I can arrow along that to where it is on the left side of it right here, and then I click enter. Now I want to be on the right side of that point, so I need to go down below here. Click enter again, and then it's going to find a spot in the middle there, which would be at my x is 2 and my y is 0. So 2, 0. So those would both be solutions to this parabola here. Now, since this is a story problem and they're asking about numbers of seconds, only one of these answers actually makes sense. The only answer that actually makes sense would be the 2, 0, because we can't have a negative amount of seconds. Okay, so that would basically be like before the water even shoots out, so that doesn't really make sense. So our actual solution here would be the 2, 0, 1, which means it would take 2 seconds for that water to hit the ground. So 2 seconds. Now, if you did actually want to graph this, and some of them on the assignment will ask you to actually graph them, what you can do to get ordered pairs that work for this is if you go second, and then see how in blue it says table above the graph button. If I click on that, that'll give me a whole bunch of different ordered pairs that I could use for this. So obviously some of them are huge, so like -6, -744, probably not one that we want to use for our graph. So we could arrow to ones that make a little bit more sense for us, so like 0, 6, 119, 2, 0, those would probably be the points that I would use for this if I had to graph it. Okay? Alright, try another one here. Okay, so again, we're trying to find our roots or our solutions to this, and they set it up with equaling 0. If they ever put equals y there, you just swap it out with a 0 because we want our y to equal 0 in these cases. Okay, so first thing we want to do is we want to graph this. So I'm going to go back to my y equals button, clear out all the stuff, and then I'm going to type this in here. So I'm going to go x squared, so x to the power of 2, plus 2x minus 15, and then it equals my 0, which I know is my y, so it equals my y there. Then I push my graph button, and I get something that looks like that. Now, if they want me to graph it on paper, and I think that that's what I'll probably have you do on the quiz, is actually physically graph this out, we can use our table again, so we can go second, and then above the graph it says table, and this will give us some points that'll work for this. So it looks like maybe if we use, I don't know, I think we might actually have to change our scale on our graph here, because it looks like, remember how we talked about when we're looking for patterns with these, where it kind of, one number, it kind of switches over and then does the pattern on each side. It looks like here -1, -16 is where our pattern kind of switches, because above the -16 you have -15, then -12, and below the -16 you have -15 and -12. So it looks like that is where our pattern kind of starts going. So if we were making a table here, I would use that point, -1, -16, as my vertex. And maybe it would be a good idea to do a little table here. So x and y, if I use -1, -16 as my middle one for my vertex. On the other side of that, I've got -2, -15, -3, -12, and then going the other way, I would have 0 and 2, or 0 and 1, and then I would have those same numbers, -15, -12. Okay, so you could just use those instead of having to do all the plugging in and stuff that we were doing before. You can just use those numbers and graph them. So we'll do that here. I'm probably going to have to change the scale on my graph here because this only goes up to 10. So I'm going to get rid of those ones, and I'm just going to count by 2's. So my first one there is -3, -12, so I'd go left 3 and down 12, which if I'm counting by 2's would be like to the -6. And then my next one there, -2, -15. So left 2 and then 15 would be 7.5. And then 1, -16, so, or -1, so -1, -16. So down like that. And then the next one, 0, -5, so over 0, or not -5, 0, -15, so over 0, so right on that line, and then down to 15, which would be at the 7.5. And then 1, -12, so we'd go right 1, down 12, which would be down to the negative 6. And then I would draw my curve in here. Oops, that's not great. Something like that. Okay, so now what we really need to do to answer this is we need to find our roots. Okay, so to find our roots, again, we can use our calculator. And we can go to second, and then the trace button, which is calculate. And we're calculating our zeros. So then we go to our graph here, and we might have to move it around a little bit to be able to find where our arrow is at. There it is. Okay, so we're going to find this one first because that's the one I'm closest to. So if I want left bound, I want it to be on the left side of that intercept point, which it is, so I can go enter. Now I want to be on the right side of that, so I need to arrow up so I'm on the right side of it. Click enter, and then enter again, and that'll give me where it crosses. So one of my solutions here would be 3, 0, or you could do x equals 3. Either of those would be fine. Then we want to find that other one. So we would go second trace button, which is calculate, and then down to 0 again. Now this one we're finding this other one here, so I'm going to have to arrow along that till I get to the other side. And this time my left bound needs to be above it because the left side of that graph is above where it crosses there. So I click enter. Now my right side needs to be below. So I click enter, enter again, and then my other one comes out to be negative 5, 0, or x is equal to negative 5. Okay, so those would be my roots or my solutions. So really here, my graph is not great because my line should have crossed right there and should have crossed right there. So that spot there and that spot there would be my roots, which would be at 3 and negative 5. So those would be your solutions there, 3 and negative 5. Okay, we'll try another one here. So this one it says estimate. So kind of the hint here when it says estimate is these aren't going to come out nicely. So we just have to figure out what they're closest to or what they're between. There will be some like this on the assignment that asks you to estimate, so you just figure out which ones, which two numbers it's between. So like between 3 and 4 or 5 and 6 or something like that. Okay, so let's go back to our calculator here and we'll clear out our y equals. And we'll go negative, and make sure when we use negative, it's the one that's below the 3. So negative x to the power of 2, arrow over, plus 4x minus 1, graph it. We get something that looks like that. If we want to graph it on our piece of paper, we can go to our table, so second table. And it looks like here that maybe numbers that we want to center around, if we kind of arrow here, would be, looks like it's going to change over right here at the 3, so 2, 3, because it goes 3, and then above that is 2 and negative 1. Below that is 2 and negative 1, so those would probably be good points to use here. So if I'm making a little table here, x and y, a good x to use, we could go, since we're centering around 2, 3, one below that would be 1, and below that would be 0, so 1 is at 2, and 0 is at negative 1. And then our other points there would be 3, 2, and 4, negative 1. So I just chose that one as my middle because that's the vertex, or where it's switching over from, you know, starting to follow the pattern. So 2 and negative 1, 2 and negative 1. Okay, so then I can graph those guys. So I've got 0, negative 1, so over 0, down 1. And I've got 1, 2, so I go over 1, up 2. And 2, 3, over 2, up 3. 3, 2, which would be right 3, up 2. And then 4, negative 1, over 4, down 1. Okay, so I kind of draw my curves in there. something like that. Now, with this here, you can clearly see that it's not really, this one kind of, my line got a little astray on me, but it's not really crossing at a specific number here. It's kind of crossing in between there and in between there. So when they're asking us to estimate these, our actual roots come out to be decimals. So when we do our estimation, you can just say which numbers it's between. So like this root here would be in between 0 and 1. So you could say between 0 and 1. And then this one here would be in between the 3 and the 4. So between 3 and 4. Okay, now if you weren't sure on that, you could also use your calculator here. So one thing you can use is the table, looking to see where it switches from positive to negative. So like positive would be up here, negative would be down here. So if you switch from positive to negative, you're crossing over that x-axis. So if you look at on your table where your y's switch from positive numbers to negative numbers or negative to positive, you can see that here between the -1 and the 2. So we know that it's between 0 and 1, which is what we had from our picture. And then same thing here, you can see that it's switching from positive 2 to negative, which would be in between 3 and 4. Okay. Another way to do it would just be actually finding those roots. So you could go second, and then your trace button, which is calculate. We're calculating the 0. Left bound will be on the left side, so enter. Right bound is on the right side. Enter, and then you can see how it's just a decimal there, so 0.2 whatever, which if you think about it, if we're estimating, that would be between our 0 and our 1. Same thing if I use, so second trace down to 0, my left bound here would be above, my right bound would be below. If I click enter, this one here is at 3.7, which would be in between the 3 and the 4. So any way you go about that, you can find your answer. I don't really care which way you use, as long as you get something that looks like that for the answer. Okay, what's next here? Okay, so find two numbers whose sum is -10 and whose product is, or whose sum is +10 and whose product is -24. Okay, so sum means adding together and product means multiplying together. So I want two numbers who add to be 10 and multiply to be -24. So one thing we could do would be guessing and checking numbers until we figure out what's going to add up to be 10 and multiply to be 24. There is a way to do this where you can kind of use the graphs and the calculators, and that's kind of what they want us to get at here, since that's what we're learning about. So what you can do is go, okay, I've got two numbers here, let's make one of them x. So we'll go x is equal to one of the numbers. Okay, doesn't matter which one, but one of them is equal to x. Now if we're looking for things that add to x, if I took 10 and I subtracted whatever the x was away, so like 10 minus 2 or something like that, I would get 8. Then what I know is this number here, 2, and the number there that I subtract there add up to be 10, right? So what I can do here is the same concept. I can take 10 minus the number that I don't know here that I'm trying to find, and that will give me whatever my other number is. So one of my numbers is x, and the other one is 10 minus x, which would just give us my missing one that would add them to 10. Now if I want the product of those to be -24, I want to take those two and multiply them, so like x times 10 minus x, and set that equal to a -24. Then what I can do is I can solve this out here, so I could do x times my 10, x times my x, so that would be 10x minus, and then x times x would be x squared, is equal to -24. Now to be able to solve this with my graphing calculator, I've got to have this side over here to be 0, which I know is against a lot of the stuff we did with equations, but you do want the one side to equal 0 because that's where our y is going to be. So here what I would do is I would add 24 to each side. So then I would have 10x minus x squared plus 24 is equal to, and then this side does come out to be 0, which is what we want. So usually when we're doing equations and stuff, that seems silly to make it equal 0, but that's what we need in a situation like this, is we need it to equal 0 so we can use our graphing calculator. Okay, so then what we're going to do here is we are going to use our graphing calculator. So we're going to take this here and plug it in. So we're going to go y equals, clear out all our stuff, 10x minus x to the power of 2 plus 24, and then we're going to graph it. Okay, so you might be wondering, our graph went up, but it never went down. Now the reason for that is because it's actually going to come down off of our screen, so if we wanted to see it, we'd have to kind of zoom out a little bit. So you could either go zoom and then arrow down to out and click enter. So then you can see where it's crossing in 2 spots, or you could change your window. So now we're counting by ones, and it's going to from 40 to negative 40. You could change that where like our minimum on our x would be like negative 5. Maximum on our x would be maybe like 15. I don't know, I'm just making stuff up. And then you could do the same thing with our y's. I'll just set it at negative 5 and 15 again. And that just kind of changes the scale of your graph a little bit, but you can still kind of see there. So no matter what, you can change it using the window or the zoom. Either way is fine, but you want to be able to see those 2 spots where it crosses. Now we want to take and we want to figure out whether those spots are that it's going to cross. So we go second, trace button, down to 0, click enter. So we got to find our little cursor guy. There it is. Okay, so now we want to be on the left side of this one here. So we click enter. Now we want to be on the right side of it. Enter, enter again. So we get negative 2, 0. So negative 2, 0 as one of our solutions. Then we're going to second, trace, go down to 0 again. Now our left bound, we want to be above. It'll come back down eventually. You can kind of see how it's going. So now it's at 24. So our top of our graph is here at 15. So we just got to keep getting close. So now that we're below 15, you can start to see it. So we want to be on the left side of it or above it. So enter. Then we arrow down to be below it. Enter. Enter again. And then we would get 12 and 0. And since our question was originally asking for numbers that would add together to be 10 and multiply to be negative 24, well, negative 2 and 12 do add together to be 10, and they do multiply to be 24. So our 2 numbers there would be negative 2 and 12. Okay? Now if it asks you to graph it, which it doesn't necessarily in this one, you can just use your table and graph that out. Okay, so this is your book page assignment here, page 472, 12 to 22 even, and you will probably want some graph paper for that. And if you've got a calculator like this, a graphing calculator, you can use it. If not, use that Desmos. Okay, so Desmos.com or Desmos Graphing, something like that, will help you to graph these so you don't have to do each of them out by hand. Okay?